Good afternoon, everyone. My name is Mae-ling Lokko, and I'm an assistant professor at Yale University School of Architecture, as well as Yale's Center for Ecosystems in Architecture. As we have heard today, the building sector is the single largest contributor to global CO2 emissions. Today, most building codes and regulations address operational carbon, that is, carbon that is embedded in the energy we use to heat, light, and cool buildings. What has not been given as much attention to is the accounting of embodied carbon, which refers to the emissions from the extraction, manufacturing, construction, maintenance, and disposal of building materials. Materials that are extracted and processed for the construction of buildings represent today an estimated 10% of overall energy-related CO2 emissions. However, over the next 40 years, this global consumption of raw materials will double as the world economy grows and living standards rise. The biggest increase in resource consumption by 2060 will be in minerals, including construction materials and metals, particularly in fast-growing developing economies. Therefore, while this estimate rests at 10% today, embodied carbon could account for over 50% of all emissions from the building sector in the near future. At the end of use phase of buildings, materials are often wasted, exacerbating the environmental impacts associated with today's take, make, and waste linear material practices. Approximately 100 billion tons of waste is used by construction, renovation, and demolition, with about 35% being sent to landfills. The transition to a low carbon built future requires the design of multi-beneficial material strategies that take a whole building life cycle approach. Siloed approaches that, like the sole focus on operational carbon, can undermine carbon reductions gained from energy efficiency. Stakeholders shown across the entire whole life cycle of the building's built environment process need to be simultaneously incentivized so that the burden is not only on producers and producing countries, but also the pressure is put on the material procurement and design practices in consuming countries, therefore closing the carbon loophole. The International Resource Panel estimates that the impacts of material efficiency strategies, including the use of recycled materials, could reduce greenhouse gas emissions in significant proportions, particularly in housing around the world. In G7 countries and China, this number could be as high as 80 to 100% by 2050, and 50 to 70% in countries like India. Due to the complexity of the built environment process from its supply chain to its recycling sector, multiple stakeholders must work together to transition to a low carbon material economy. This section in the report focuses on materials, discusses multi-stakeholder collaboration according to key strategies: avoid, which is building better with less; shifting, using low carbon alternatives; improving, which covers decarbonizing conventional material systems; and adapting, focusing on reducing operational carbon. As global cities are under increasing pressure to reduce their greenhouse gas emissions, linking the impact of material choice to building and urban scale carbon reduction extends the transformation opportunity to reduce the negative effects of concrete surfaces and transition urban areas from net carbon emitters into carbon sinks that absorb greenhouse gas emissions. A whole life cycle and systems approach is needed to assess the upfront embodied carbon cost of any building material system. Considering the potential opportunities of material assemblies for operational carbon savings, be it through reduced building, cooling, and/or heating loads, reduced urban island heat effects, improved air quality, and biodiversity, exist at both the building and urban scale. For example, while highly dependent on climate type, system design, and comparative building insulation requirements, living wall systems have been shown to significantly reduce cooling on a building scale by as much as 58% compared to exposed concrete masonry systems. For most global locations and building types, operational carbon savings, as well as ecosystemic benefits outweigh the upfront embodied carbon costs. The report also focuses on 3 spotlight case study contexts: Ghana and Senegal, India, and Finland, all of which highlight the status and the thematic strategies looking at decarbonizing our building materials sector. For the West African region, focusing on Ghana and Senegal, we look at how the building sectors in both contexts are entrenched in high carbon growth pathways. Instead, low carbon building material alternatives are explored. For India, where the impact of material choices on cooling is critical, understanding the material footprint across the informal, semi-formal, and formal housing typologies are key. And lastly, the impacts of greenhouse gas emissions on a neighborhood scale are explored in Finland, highlighting the importance of using tools not only to assess the material emissions of existing building stock, but to proactively use this in urban neighborhood planning. Thank you.